All right, 7 o'clock. Let's get started. Today it's at this hour, 7 to 7:55. We will do the review. Okay. Review sessions, as I mentioned, it's to give you the big picture, especially for those of you who are new to programming. All right. So I will do it for lecture one and lecture two for today. And each week I will do one lecture, except for this week that we have two lectures. All right, so you may have questions and you feel free to ask, and I will try my best to answer them. And if I can't, and you appear in the forum. Actually, the forum, I will put the, if you go to the forum, in the review and reflection on lectures, I will be posting some questions here after our session, and you feel free to answer them and share your know-how. All right. So the review is to summarize the main purpose of each lecture and is not to revegetate whatever it's discussed already in the lecture. All right. So at time, because lectures are very concise, I can't do it in that particular manner, but here I can freely explain a certain whatever you call philosophy or background or thinking and so on that will help you in understanding the material and why certain things are there. All right, and the recording will be available the next day. As you know, my speed is like that. If you are not comfortable with it, you can always play at 1.5 times the speed to get a much smoother way of listening to the lecture. All right, any question? Yeah, okay, give me a check. You know how to make a check? Just a tick. Yeah, okay. I see some of them. All right, so for review, I will be doing most of the talking, while later on at 8 o'clock in the recitations, I will engage you more that you can help each other. By no means we're trying to make fun of anyone. Just that if you make a mistakes, that be your honest mistakes, and that's fine. And in fact, that will be good that you make mistakes that you learn, and you most likely will remember it forever because you make the mistakes. Okay, so we are not trying to make fun of anybody, but just to engage our discussion. All right, so let's start. The review is on lecture one and two. There are three parts that I want to do for today. That it's the kitchen cooking. As you will see, actually, in computer, lots of the things that we do are actually very much like a lot of things analogous to many things in life. In this particular case, I want to associate it to cooking, and you will see shortly why it is so. The second part is on the lecture two on the functional abstraction, and then the last part I needed to go through some of the more difficult things like the recursion. How do we understand syntactically versus semantically? All right, so let's start with the kitchen cooking. So, as I said, lots of things in computer, it's very much like real life. It is how you are going to associate it to the real life. Many people may, for example, in the study of law, it's actually very similar to study of computer programming. In law, you make a lot of contracts, and all the contracts with clauses actually they're trying to catch all the various situations and try to make it as complete as possible. In writing program, you will see that indeed we are also doing the same thing. Right. The first thing that we do in the our lecture one is that I emphasize a lot about either. Either is you can associate it to like a kitchen facility. It is a kitchen. Different programming environments, different language has a different kind of programming or kitchens that you can use. And some of you may be familiar with Visual Studio Code, which is from Microsoft. And this is free. You can download it for your use. Of course, it's much more sophisticated than our IDA. But by no means, if you use this, you may be a little bit of convenience. You can do some of the complete autocomplete. You can do some other more sophisticated stuff that, but in any case, as far as I'm concerned, as far as this course is concerned, there's no particular advantage that you use Visual Studio. In the case of a practical exam, if you use this, I have no issue, except that you are not supposed to ask whatever it's there, like the co-pilot to answer any of these questions. So, other than that, you can use Visual Studio. And Dr. Java is just another environment, another kitchen environment that you use it to code, to do Java. Eclipse, VIM, all these our old-timer people who like it without having to use mouse when you do programming. Okay, so any of these are considered like it's a kitchen facility, and different kitchen facility has different ways of doing certain things, but all in all, they are there to help you to code out your program. And there's the thing that you needed to know is that there are compile versus the interpretative language. Okay, so the compile means that, for example, Java, it's a compile language, which means that the program has to go through some analysis before it can be used to run. As such, these are more strict and a lot of things can be caught when you do the compilation. On the other hand, interpretative language like Python that we're on, things may be much easier to use, but a lot of the thing may be missed out that it doesn't catch it until you go through that statement. You see that. Now, so this is the picture of, I wanted to say it in B. All right. When I say that it's a kitchen cooking, I meant that you're doing the algorithm, the program that you're writing, it's just like recipe. Okay. We use the word algorithm and program interchangeably most of the time. Algorithm could mean things are more concise. You don't have to detail out every single steps. On the other hand, program actually has to tell computer precisely what you want to do and statement by statement. On the other hand, algorithm could be just some pseudo language like normally we use English to do it. All right, so I wanted to say that kitchen, when you're writing algorithm, it's just like recipe. Why? In the algorithm, you are actually having, okay, you are step by step. We read from left to right. To understand the arithmetic operation. Iteration, there are three things that you have to see here, basically sequentially, and then iteration and conditional. Okay, so these are the three things that dictate how your program will run. Now, if you take a look at the recipe, I think I have it here. Where is it? Okay, let me just get it. All right, like making a simple white cake. Uh, so you have step by step, you can see. All right, then the step one, step two, and so on. That is your step by step. Iteration, recursion, this means you can find a lot of until statement, until, all right? So this means iteration. And conditional, that means that you want to do it for, like how many minutes to stir and so on. So, all right, so all these are conditional. Okay, so writing a program, it's nothing more than making a recipe. In the case of recipe, is making a cook a dish, whereas our algorithm is to finish certain computational problem. All right. So all in all, they are in the same nature. If you can associate that, then you are pretty much, to some extent, you already studying everything that you needed to know. Once you include this particular one, ingredient is actually data structure. All right, so here got some ingredient we saw just now. All right, ingredients. So these are the data structures that you're going to use to do your cooking. So in actual fact, I wanted to say it's that these are the two things I wanted to say. All right, a dish is simply a recipe plus the ingredients. Computer science, it's algorithm plus data structure. And this is what you see in our roadmap. All right, so this part, it's the algorithmic part. This part, intermediate, the list processing, the multiple representation, these are the ingredients. And then once you know the algorithm and data structures, you go to the advanced part. This is to help you to cook. So for example, you know how to cook fish curry, then you will be able to make it into chicken curry and so on. All right, so these are the kind of generalizations that you can do. So remember, that's everything that you needed to know are pretty much here in this course as well as in many other courses in computer science. Of course, some of these things may come in disguise to you. They could be called protocol. That yeah, actually they are also a form of algorithm. But all in all, what you're seeing in computer that making things, making all this wonder in the world, it's because of the algorithm and working together with the correct data structure. All right. So your goal for this course is to master a few of these things because you can't finish it in all. You can't gain a lot of in such a short time, 6 months. But you would have enough to know that these are the basis that you can then build on top of it. And the data structure, again, data structure is a very deep subject. What you're seeing are tuple, list, tree, and dictionary, and so on. But actually, mix and match, you can actually make a lot of things. And they are actually what drive all these years. The algorithm get faster and faster. All right, so the thing that I've said is this. All right, once you know how to cook, for example, cooking chicken curry, then you will be easy to cook curry fish head and so on. All right, so lecture one, slide 48. All right, so in the hmm, in the elements of programming, basically these are the compositions of things. So what you first got from us will be the primitives. And then this is just like in mathematics. Now I'm switching. I'm trying to show you all various kinds of analogies that hopefully it helps you to associate things and then you don't see them as so strange. All right, so primitive means things that we give it to you. You don't question them, you just use them, they are there. You have to believe that they are true. So once you hear that, you probably will need to, you can then associate to mathematics. In mathematics, we give you axioms, and then you build a lot of theory, you prove theorems and so on, based on the axioms. Okay, so in programming, we give you primitives, and then your job is to then make things combine together to make the wonder, to make a program to do certain thing. And then once you know how to make a wonder, how to do certain thing, you do combination. Then you then do some abstraction to abstract it out. Like you to cook curry chicken, you don't have to cook curry chicken. You just put in the cooking curry into your recipe, and then you just take out chicken as a substitute as a parameters. All right, and that can be an argument of fish head to substitute the chicken. That's the means of abstraction. All right. So for the case of primitive, we have all these primitives. So you are given numbers that you can work with. You are given string that you can work with. You are given arithmetic operators, comparison operators. All right. And then many more logic operators. And you have to understand truth tables. All right. When A is true, but not A means false. When A is false, not A means true. A or B means that A is true or B is true, then it is true. A or A and B, you guys are quiet. It is everything okay? I see somebody's is okay. Okay. All right. So A and B then means that both A and B must be true, then you get true. So B is true, A is true, then true. Otherwise, everything is false. So understanding these few basic stuff that given to you as primitive, your job is then to make things combine together to get what we needed. All right, so let me just cut this down and show it. All right, this is similar to study of math. Element of this is primitive and the raw ingredient and so on. All right, so that I finish the lecture one. Basically, we're throwing you into the idle environment, and then your job is, or your exercise is to play with it and get you acquaintance to it, and then you can then make a dish. Any question? You okay? Give me a check. Oh, yes, there's a question. Yes, go ahead.
Just now, right? Were you screen sharing or were you just like talking? Because we couldn't see anything.
Oh my God. You didn't see anything? Anyone else? Yeah, I'm still screen sharing. Somebody said.
Oh, wait, what? Okay, wait, I'll double check.
I think it's your screen. Anyone else can see my screen? This is our first lesson. This hiccup is expected. All right. Um, okay, so great. I think yours is isolated, bro. You have to sort it out. Why don't you log in and log out and log in again? Okay, let me go on to the second lecture. All right, second lecture is functional abstraction. Now, when you learn a new language, all right, Python is a new language. So there are things that you got no choice but to then follow it. There are rules and regulations. All right, like in English, you have all the grammars that you have to obey. Same for the Python. So you must have proper indentations. You must be able to define things before you use it. You must assign values to a variable before you use it, and so on. All right, so all the idiosyncrasies of a language, unavoidably, there are some. Like, for example, in English, you have I'm a boy rather than I is a boy, or so even though I is a singular, but it is a single, but then I am rather than I are or I is. Okay, so idiosyncrasies, it's unavoidable. You have to live with them, and otherwise, they are things which are pretty natural, and then you should be able to know them without having to remember them by heart. All right. So the trick is that you for those things which are unusual to you or unnatural to you, you got no choice but to memorize them. Otherwise, most of the things are pretty much natural. Okay. So in the functional abstraction lecture two, pretty much we are throwing you with the we are throwing you with the uh, a function. We just give you all the stuff that, in particular, in this case, a picture language, a language that helps you to deal with pictures. And the language actually is built there, and you can use Python to work with all these functions. All right, so functions are given. It tells you what are the input and what are the what will be the output. All right, so this is what is the setting. The setting is that we give you a language which you can call it as a picture language, and you can then uh, uh, do whatever you want to do, a lot of stuff that you can do, but you do not have to know what is inside the function. Basically, that's it. That is what we are given. All right, lecture two is to throw you in the deep end in a way to start using the picture language. But you will see that this is no difference from you play with Python directly, but picture language is more interesting because you can see the thing that you create directly. So giving you the picture language is it's a good thing that you can play with it. In here, there are some of the stuff that I'm going to tell you what you have to take care of. So this picture language, it's actually one layer above Python. All right. So this is very common in computer science. Lots of the things are built on top of each other. All right. So you don't deal with the lowest level, which is all the electronic or the circuitries. You don't deal with the next level and so on. You are above at the OS and above OS with some people who wrote the Python interpreter. All right. So this is the common things in computer science. You do layer by layer. You are working on a particular layer. And the layer that you work with, you only need to know what is, with respect to this guy, what is the, given certain input, what is the output. So this thing is the functional abstraction. It's abstracted that you have to, you know what it does, but you do not know how you do it. Okay, you don't have to know how it does it. In fact, you can open up the picture language, the Python code. There will be a lot of things that it will swarm you. So it's not at our level to look at it at the moment, but you can see that there are a lot of the things that built for you. And this picture language is actually one level above the Python. All right, and it is built on top of Python, and you can just use it like a Lego block, and you don't have to do, you don't have to know how it does it. Just then you have to use the step-by-step repeating and the conditional. Now, just now I didn't mention repeating means that it's either doing an iteration or recursion. All right, so for now, lots of the things to you are in the recursion. Okay, iteration, you need a special another construct, but that's not really difficult, but we'll see. Actually, in the past, we used to learn iteration before recursion, but now recursion is pretty natural that it tells you with wishful thinking, you see this word over and over again in the videos, and you basically you assume that you can solve it with a smaller problem, and therefore you can solve the larger problem. Okay, so now I need to tell you what are the difficulty. There are two difficulty, a technicality. Now, the first technicality is indeed the repetition, which you want to do it as an iteration or you do it with the recursion. All right, so the step-by-step, it's referring to this one. This usually means that from you reading from the left to the right and top to the bottom. So programming language generally work in that manner. You read from the left to the right. There are some other languages in the world is reading from the right to the left, but programming languages like Python is reading from the left to the right. And this particular step, it's not difficult. You can read it. And conditional, it's always not difficult too, but conditional usually is built within the recursion, all right, so that it can stop a certain point. Otherwise, the recursion will keep going on and never end. Then if it never end, then there's never ending to find solutions. Okay, of course, some of the real-time systems in the world does require the system to keep on running. But in our case, we are not in the real-time system. We will need our program to stop at some point. Okay. So the technicality in using this functional abstraction, as many of you must have tried mission 1 and mission 2 on creating runes. Actually, you will find that your cell is swarmed. It's in a deep thinking about how to do the recursion, how to do this repetitively, right? And that it's the technicality. Then the other thing about the technicality, besides this, you can claim that you don't have experience. Yes, most of you may not have experience, except for a few of you may have some programming background. Problem solving, it's a skill that you have to build. Basically, you want to be able to come up with this kind of stuff for some standard way of solving problem. That is to say that at some point, uh, you are at this level, okay, that you know there are standard way of solving things, then you are already at certain level of master, not completely a masters, but a certain level of mastering the skill that you can solve the problem. So, and you can see here that there's dynamic programming, which is a way of solving problem, memorization, which is a way of solving problem, searching and sorting, which is yet another way of first processing the problem and then solving the problem. Okay, so you would have to collect some of this skill along the way, and I will have review sessions to talk about this. The more compiling a few more things that can share with you that will help hopefully. All right. Otherwise, you got no choice at the moment. You have to learn it in a hard way. But one thing you can do is that whenever you have a big problem, usually you break it down into smaller ones, and then you hopefully can solve each part by itself, and then you solve combining the solutions for each part, then you can solve the problem in at a whole. All right. I put down here the 10-year series as analogies to what you have been learning in your JCs or in your polys, where you actually look at some past year questions and learn it. Yeah, there's one way, but of course, we do not want to revegetate whatever it's in all this. Usually, we want you to be able to think about things. Okay, of course, there are books that are written about it and how to solve it. There's one book that I can think of, and you can actually read it and see some inspiration there. Some of that book is written in solving mathematical problems. Okay, so that are the technicality that of the functional abstraction that you have to solve it. But of course, in the specific to picture language, I would like to say a little bit. All right, for speak, there's all right, for picture language, the primitive are the things that are given to you. So what are the primitive? So just now when we talk about Python, the primitive are this kind of stuff, the numbers, the string, arithmetic, comparisons, and so on. For the case of picture language, the primitive, okay, it's just another level given to you are here, just these few things, all right? And of course, you can combine with the Python primitive. So primitive given are this. Maybe try to, is there a way for me to clear the screen? Somebody draw on my screen here. Okay, anyway, so the primitive are here. So your job is to understand all these primitive And also, in the case that the data are given to you, R cross, Nova, Seal, and so on. All right, so your job is to make use of these things to come up with the picture that you're asked to do. So after knowing this primitive, what's the next thing? It's the means of combination. Of course, means of combination means that you're putting two or more things together. All right, how do you put two or more things together? Here is one thing. You can have show it, you can turn right of it, and that is making things. Of course, you can still use the Python stuff, but it's not relevant here if you are manipulating pictures only. So these are the thing that you combining the picture, put it into quarter turn right, and then put it into quarter turn right again. So this quarter turn right, turn right, so you turn right 2 times. So this is a means of combination. All right. So okay. Then the last thing is that means of abstraction. Before that, actually, I should say that the technicality of all this, are it's in the case of precision, in the case of picture language, you actually don't see this, but you will see this in the Python itself. 2 plus 3 times 4, it's actually 14 rather than 6, rather than 5 times 4, 20. All right, so this is a precedence rule, which you learn since young, that you know that multiplication and division comes before addition and subtraction. And the other thing is also associativity rules. So 2 star star 3 star star 4. What does this mean? Does it mean 2 raised to the power of 3 raised to the power of 4, or 2 raised to the power of 3 first, then raised to the power of 4? All right. So all these things. All right. So you have to refer to the. I will have the link for you. You will have to refer to the precedent and associativity rule. So precedent rule is got to do with who come first, right? Whereas associativity rule is it left to right or right to left? When you have two things of the same precedence, who come first, right? This star star and this star star are the same precedence. Of course, they're the same symbols, and who should be done first, right? So there's this thing about left to right and right to left. Okay, so you have to study this in terms of the technicality of dealing with means of combinations. Of course, this dealing with numbers are not particular to picture language, but got to do with the whole Python, the Python as a whole. Okay. So let me just. All right. So this is the link that I use, and here are the thing. Okay. One thing to note is that in some in this is one of those idiosyncrasies I mentioned. So this is possible in Python, but not in other languages. So you can write things like x less than y less than z. This has nothing to do with associativity. So this is an idiosyncrasies that you have to remember by heart. This is in Python. This means that x less than y, n, okay, the n, y less than z. So you are evaluating this in this particular manner, whether it evaluates to true or false. All right, we'll come to this afterward in the recitation. Okay, so one thing that I should point out to you is that, all right, so in the case of means of abstraction, which will come shortly, uh, the when you look at this, until a certain part of the video, this started to ask you question about, can you create this picture? All right, from this picture, you can create this, you can create this, but can you create this? This thing this is all even numbers. So this 2, 4, 6, 8. This is 2, 4. This is odd number 1, 2, 3. This is 3 by 3. So at certain part at lecture 2, slide number 57, you will see this question, and this is telling you that the primitive given to you, it's not enough. It's not enough to do things like this. All right, and this is unusual in the a complete language. If the language is complete, it shouldn't be not allowing you to do things like this, which look so obvious. From 8 to 4 to 3 should be possible, but why can only do from 8 to 3, 8 to 4, not to 3? So it means that the primitive given to you, it's not good enough. All right. So it's not possible. So the lecture at lecture 2 at slide number 60, it gave you this additional primitive to augment the primitive. Basically, it says that the whole system that created, just like in the axiom given to you, are not enough. You need to augment the system that you're working with additional things which you do not have to know how it come about, but you need to know the truth of it. And therefore, this is given to you. And then now you can then make picture like this. All right. So this is one thing that you have to know. In the world of computation, indeed, there are also situations like this. No matter which language you use, there are things which cannot be computed. Okay, you will come to that. That basically, the axiom given to you, it's complete, but yet there are things in the world that you cannot do computationally. All right, so that is actually the truth. But here in the picture language case, we could have augmented it. We could have included this thing for you in the first place so that you could already started to create this, but we didn't. Just to make a point that sometimes the system is not complete, and therefore you have to watch out for such a thing. But bear in mind, in the world of computation, we sometimes really cannot do certain computation. All right, that is a fact, and you will get to that fact sometime in your study of computer science. Okay, one part of it, the next I need to talk about the means of abstraction. All right, means of abstraction. Why is A again? I mean to have this. This is the third part. Shouldn't be A. Okay, so this is means of abstraction. It's to how to abstract into yet another function. All right, you saw the so picture language is yet another language. So just like Python, we have primitive, we have means of combinations. We also have means of abstraction. So abstraction, it looks something like this. Basically, you know how to do certain thing. Then the next thing you need to do is to make it into a function, define something, and then give them parameters. All right. So this is a means of abstraction. Okay, so means of abstraction involving the things like basically you're giving variable names. Writing a program is mean there's one thing that you have to remember. The writing a program, it's meant for other people to read in a way, or not just that it's for execution that get you the answer because programs as in the world generally can cause trouble or bugs or because of wrong assumptions. And therefore, it has to be corrected. And usually, correction is not done by somebody who wrote the program because the guy may have left the company or may have left the task for a long time ago. All right, because problems occurred generally after sometimes it's not immediate. So the person who wrote it may not be there anymore. All right, so you must always be remember that programs written is meant for other people to read. All right, as such, you have to be careful with all the naming and so on. X, Y, Z are not good names. ABC are not good names. Usually you have to give names like, for example, here repeat patterns means repeating some pattern, reading to, n times with this particular pattern on this particular picture. So it makes sense. All right. So repeat pattern is a good name here. Okay. So remember that writing program is for others people to read. All right. So the means of abstraction is meaning that to define the function to enclose a bunch of statements. So this repeat pattern is to enclose all these statements into a function. All right. So what are the technical difficulty here? So here are the technical difficulty. All right, the technical difficulties are on scoping, all right, of the variable. This will be in your future exercises. Remember the word scoping. Scoping means that where does this particular variable apply or is valid? Okay, so it's not that when you, for example, when you write n here, this n is valid within this function. When you go outside, you cannot see n anymore. So the scoping of n, in this case, is within this function. Or outside, you can have another n, which is out for referring to other things. Okay, so technicality is on scoping and also the lambda format. Okay, this is something that not in most other languages. Lambda function is a function without name. Basically, you can define a function without giving a name. In this cases, there's a name here, but in some other cases, we just write lambda blah 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 blah. Okay, and that it's a function, but that doesn't have a name. We needed that because we have high order functions and so on. So we will see that. So lambda is yet another difficult or another more involved structure that you have to learn. Okay, of course, repeat, it's again a repetition, which is again the way, for example, here, how can I know that I can just do this pet, repeat pattern, n minus 1 pet, then the same thing to give me this nice picture. All right, so this is that's the power of computer program. A small little few lines give you wonderful things like this. All right, so how do I be able to come up with this? In fact, this will take some time because this is problem solving. This actually in problem solving, this is not the only way to give you from here to here. I'm going to post in the forum later on to write this in a different manner to give you the same thing. Okay, so I will put that as a challenge in the forum. All right, so basically you can write this part differently while you still use this show repeat pattern for comma, make cross, comma, nova, bb to give you these things. So basically, there are always many ways to do the same thing. But of course, there could be a better way, meaning that there could be a simpler way also, which we will favor that. We don't like complication because the more complicated, it's more difficult to understand and more difficult to ensure its correctness. Okay, so that is what it's on the lecture 2, the difficulties and the kind of story behind what you are doing. Any question? You okay? Give me a check if you're okay. Okay, all right. So yeah, let me go to the last part, then we can take a break for the recitation shortly. All right, the last part is to do some tracing for you to see. So syntactic, it's versus semantic. All right, so for example, when you write a code like this, it's always difficult to know what it means. It only tells you that syntactically it's correct. You put in this picture, you write this, you do show this, you get these answers. And how do you know that if I change this to 5, what would it be? That if you can make that out without doing the explicit tracing. Tracing means that we go through the statement by statement and see what happened one after another. Then you are then understanding the semantic. So in this case, you can see that the if you try 3, you will get to the power of 2, which means you will get this square here. Okay. So how do you know that? So if you change this to 10, for example, you do not want to go through this function yourself 10 times. 10 it means 10 times, yeah. And to realize that in fact this thing is getting you to the power of 10 number of these crosses in the picture. All right. In fact, because of this very heavy recursion, to the power of 10 may not be executable also in this system in my computer. Anyway, we wanted to understand semantic. For us to understand semantic, I mean the meaning of this code, we have to trace the program. All right, here is how you will trace the program. Here's the program, right? It's the same as this guy. Okay. Then we want to know what is going on by doing step by step. All right, how do we do that? This is possible when n is small. So we are going to put in a small n. In this case, our n is 4. All right, so we have this. So we want to understand what is this 4 comma make cross, which is here, comma nova. This is the pound sign is the command. N equal to 4, pet, the pattern, pet, it's actually make cross. All right, and then the picture it's actually nova BB. Okay, so nova BB looks like this. So what does this do? So when you take this, so n is 4, 4 is equal to 0, no. So you will return this guy. So you return make cross. All right, pattern is make cross. Repeat pattern again. So this repeat pattern. And then n minus 1, n is 4, n minus 1 is 3. All right, so 3. And then make cross. And then nova BB. Okay, so we get this thing. But again, this thing is not something which is primitive because it's a function composition. So we want to see this further. What is this? So in this case, n is equal to 3. Our pad is still make cross. Our picture is still the same. Yeah, maybe I make it smaller or so that it's within a line. Okay. All right, so we are here. We are make cross, which we know how to do. Repeat pattern, oh, we don't know because it's a function. So we need to again substitute this 3 into it to see. We have to make it into it. So we now have a make cross, repeat pattern. The 3 is minus 1 is 2 now. Okay, so we have this. Again, we have make cross, we know. Make cross, we know it's a primitive. Repeat pattern, it's a function. So we have to substitute this 2 into it again, and so on. I need to make it smaller. Okay. Okay. So we have it here now. Make cross, make cross, make cross, make cross. Repeat 0. Make cross, blah. And when 0 goes in, we get n is 0. So repeat pattern. So, sorry, return picture. So now we can substitute this with the picture, which is Nova BB. So we are now coming out from the deep recursion. All right. So we have substituted this repeat pattern with this Nova BB because it say that if n equal to 0, we just return the picture. Okay. So now we have make cross, make cross, make cross, make cross, Nova BB. And we know how to do make cross, Nova BB. All right. Because we are getting a cross, which is a star. All right. We get a star. Then you have make cross with a star. You will get the 2 by 2 star and so on. And you make cross of the star 2 by 2, which is this one. You get star 4 by 4. And you make cross star 4 by 4, you get star you get star 8 by 8, which is this. Okay, so this is how you are now understand that the function here is to give you 2 to the power of 4 stars. Okay, with this particular action. And therefore, if I change this to 10, now you know that if you say repeat pattern 10 comma make cross Nova BB, assuming no error because sometimes you run out of memory, then you will get 2 to the power of 10 patterns of this star. All right, so this is how you do some simple tracing once and not always. And then you can then get the semantic, in this case, the meaning of it. You know that it means raise 2 to the power of something. The n is the 2 to the power of the n. All right, so this is how you should learn how to get to understand certain things. All right, here, let me just give you another example without doing it. You can check it through uh, yourself. This is another code uh, from your lecture notes. Stack n is to stack n pictures together. So what does it mean by this? It's here. It's a Nova 1/3 on top of Nova half using the remaining 2/3. All right, so this is how the things work out. And that's all I wanted to cover for you in the review. Hopefully, this helped you with understanding the lecture 1 and lecture 2. They are particularly important, and they are the probably you once you can get through this, then life should be much easier. Any question? We have a few minutes. Hello, are you there? Give me a check if you are okay. Okay, Selva Ganas, are you there?
Yeah.
Did you see the screen?
Yeah, I fixed it.
Okay, great. Otherwise, you can come tomorrow. You have any question? Okay, I will post in the forum the question that I just asked. Find me another way to write the same program, meaning that the same in semantic to achieve uh, repeat pattern. Okay, I will post that after my lessons with you. Okay, if not, then let's take five toilet break and we come back at 8 o'clock. All right, 8 o'clock. Let's get started. This is recitation number one. Unlike the review, I talk all the time, but recitation, I will try to engage you. I hope that it can help us. No problem if you make mistakes. You just have to be prepared. And making mistakes is for all of us to learn. It's not trying to pick on anybody. Don't, we can't see your face anyway. Well, of course, it will be good if you can show your face while you're answering questions. All right, that's uh, I mean, basic courtesy if you want to say, if you want to believe that. Okay, so the recitation number one cover all these points. Fun with either assignment and operation, Boolean operation, a conditional statement, and function. I guess you can hear me, right? Just give me a check if you do. You can see my screen, huh? Okay, great. All right, so one thing that you should know is that the simplicity is the best virtue. All right, program is written for other people to read, not just for yourself. The choice of variable names, function names, recursion versus iteration. And we talk about precedence, associativity. We'll put in the parentheses to make clear things. All right. So this particular lecture, there are three parts that you saw just now. The sequential, there's nothing much to talk about. It's just simply reading from the left to the right and top to the bottom. And then the repetition, which we will encounter that over and over again in subsequent recitations and tutorials and so on. For now, today, we want to focus on if else in here. All right, if else, it says that if the statement is true, then you do this. Otherwise, if this part is true, you do this. Otherwise, if none of this is true, then you do this other thing. Okay. You write, normally we write in this manner, but we also write in this other manner on true if expression else on false. Basically, this is the same as checking that if expression is true, the on true is here, otherwise the on false. So this is in a way like a shorthand, a way that we needed at time because you will see that we need it in writing it in this manner when we're dealing with lambda function. All right, so let's try a little bit on this kind of stuff and see how you do. All right, so if 5 equal to true, else, where am I? Okay, let's try uh, Xavier.
Yes.
Yes. Can you tell me what is the answer for this guy? This is to
Five.
say, huh?
5.
5? Why you think so?
Because the 5 will be treated as true.
Okay. And then,
That's why the 5 equal true will be true. That's why it will be
okay, then
5.
you use the fry as the true part.
Yeah.
Okay, Xavier, you're wrong.
Okay.
Okay, why? Because 5 is equal to true is not correct. 5 is false. Why is that so? 5 is considered 5 is considered to be true, but not equivalent to true. Okay?
Okay, can.
All right. Because this is the if you were in the lesson just now, these are the kind of idiosyncrasies that you got no choice that you have to remember. All right. Okay, how about another one? One. Anyone? Ethan. Ethan Lim.
I think the answer is 5 because
Why?
1 is equal to true.
Uh-huh. And 1 is equal to true. It's considered to be true, like 5, but it's also equal to true. You're correct. Okay.
Okay, thank you.
Okay, so this is the another, if you like, in the video, if you watch carefully, I did try my best to tell you that 1 is true and is equivalent to true, but 5 is true, but it's not equivalent to true. So that is to say, so Xavier should know if 5 else 2. What is the answer, Xavier? Hello, Xavier, you were
Yeah,
there?
yeah, I'm here.
Yes. What would this be then?
Is it 5?
Yeah, okay. That's
Okay.
5. Because 5 is considered to be true, but it's not equivalent to true. Okay. Let me see. Okay, we can try a few more. What about this? Let's try another guy. Asmit. Asmit.
Yes.
Okay. If 2 print yes, print y, else print n. So what's the answer?
It should be Y, right?
It should be y, right? Yeah, y.
Because 2 is considered to be true.
Correct.
So
All right, this
it's
is the
5.
same statement as here. Okay, great. Okay. Okay, one more. Let's try. Ajay.
Hmm,
Mm.
5 is true.
Uh,
I think it's 5.
the thing is 5.
Yeah.
Okay, this is a trick. This one is syntax error.
Oh,
Oh, why?
because we never define 5 equal true.
No, because return is not possible. You don't have a function. Return also only happen inside a function.
Okay.
All right, so if you have define x or whatever, if 5 equal to true, return 5, else return 2. This is okay. All right. Does it
Okay.
make sense, Ajay? Okay, great. Okay. We are now, okay, maybe this one is the same as before, just to show it to you. Okay, this one. How do I say this? Brighton. Hello. Ming Shen Fu. Brighton.
Yeah, hello.
Hello. Yeah, how do I call your name?
Brighton.
Brighton. Okay. What is the answer for you?
I think it's 2. Oh wait, there's an error, I think.
Is an error? No, it's
Oh,
no error.
then I think the answer is 2.
The answer is 2. Why?
Because 5 is not equivalent to true, so
Okay.
given 2.
Yeah, so this is what we learned just now. Okay. We learn here. So this is 2. But you see that I play with it to learn all these things too, because some of these idiosyncrasies are not documented. You have to find out, or maybe the language itself is not it's not so funny. But then if you don't try, you won't know. Okay, so this is what you have. All right, so problem number 1. What is problem number 1? Okay, here. This is problem number 1. So this is a table about operator, plus, minus, and so on, dealing with integer, dealing with floating point number, dealing with string. So column by column, let's try integer. Let's Huang Keqing, Qi.
Yes.
Huang Keqi.
Yeah.
Yeah.
Hello.
Can I do operators plus for integers, minus, and so on?
Oh, yes.
This question asks you whether in the following table put a cross in the appropriate box corresponding to the argument operator combination that result in error. Would there be any error if I do this?
Wait.
Mm,
For everything, right?
yeah,
For
everything.
all the operators.
Everything. Sorry?
Shouldn't have any error.
Okay, great. So everything is okay. So integer, you can do anything with them, with all these operators. No problem. Okay, so this is okay. Next, let's continue. Floating point. Anything I cannot do?
Uh, should be all okay, right?
Okay, but there are some strange thing. Okay, let's do one by one. So for the integer, that I should mention that integer. So what should be the answer of 2 times 3 raised to the power 4? What is the answer? Let's see. The answer is this, 162. Is it the same as 2 times 3 raised to the power 4? No. Is it 2 times 3 raised to the power 4? Yes. So what is this? What is it happening here? What is happening here? I told you just now that we read from top to bottom, left to right. I'm reading from left to right, 2 times 3 to the power of 4. But then it happened to be 2 times 3 raised to the power of 4 first, then 2. What is this thing called?
Is it
This
precedence?
is the, okay, this is the precedent. So the precedent of what against what? What is the precedent? The precedent of multiplication is higher or lower than the precedent of exponent?
Lower.
Lower, yes. So the exponent you see is here, number 4. Multiplication you see is here, is number 6. So this is higher than this. Okay? So whenever you see this, it's the same as 2 plus 3 times 4. The precedent of multiplication is higher than the precedent of plus. Precedent of multiplication, it's 6. Addition, it's 7. All right, so that's why you do 3 times 4 first before adding to 2. Next, what happened to 2 star star 3 star star 4? So this is equal to this. Is it the same as 2 star star 3 star star 4? Oh, no. Is it the same as 2 star star 3 star star 4? Yes. So what is this? 隔起
Yeah.
Yeah. What is this? Why is it, again, I'm reading from the left to right, but then this it's doing the 3 raised to the power of 4 before raising it to the power from 2.
Because you got a bracket.
Oh, no. Okay, I mean this one. This one.
Uh-huh.
Yeah, of course, with the bracket is the highest precedent. 1. First. Associativity, left to right. So what is happening here? Exponent,
It's because
right?
the associativity is right to left.
Correct. All right, so this associativity is right to left. All right, so that's why you get this answer instead of this answer. Okay, so I wanted to point to you that integer operations, all right, whatever numbers operators, you have to respect the precedence and associativity. Okay, so don't forget these 2 words. All right, let me try something else. This one. Let's see who is there. Chong Wei.
Yes.
Yes. Okay, what is the answer for this guy?
True.
True. Why?
Because as I think you showed just now, this is split into -2 is less than 3 and 3 is less than 5, which
Very good.
is
Okay.
true.
Okay. So this is true. So indeed, this is the same as this. Okay, great. What about this? Let's continue. Way.
Mm, I think it will be false
Why?
because false in this case can be treated as 0. So 0 is not less than 0, but 0 is less than false. No, true, which is 1.
Okay.
So it's a false and true. So it becomes false.
Okay, very good. Okay. So false is less than false is false. So there's no promotion of what you're talking about is false is equal to 0. But it doesn't need to. False can be less than false to give you false. If there is a promotion, then it will become 0. Let's try. What do you think this will be?
This still false.
Still false? I think my guess is 0. Oh, it's false. Okay. So there's no promotion here. Oh, of course. Logical operation, it's giving you true and false. So whatever number is, I don't care. So 0 less than 0 is still false. Yes. Okay. So you know this. So what about this one? Survey.
I guess it's split individually. Like 3 is more than 2, 2 is and 2 is less than 3, then it will be, so it's all, and which results in this entire thing being true.
Okay. Very good. Okay. One more.
This true,
Hmm?
true.
True. 1 or 2 and 3.
No. I think one or two starts first because it's
Okay. So 1 or 2 give you what?
one or two gives me 1.
If it's 2 and 3, give you what?
2 and 3, which is 3. So it will be
Okay.
1 or 3. 1 or 3 means 1.
Okay. All right. So let's put it back. 2 and 3. So this 1. So if we put 0 or 2 and 3.
Then you start with the 2 and 3 first, which is 3. So if 0 or 3, 0 or 3 means it's 0.
0 or 3 is 0.
Wait. 0 or 3. No, it's 3.
3. Okay. All right. So you have to watch out for all this. All right. Next, just now I was talking to who? I was talking to Ke Qi.
Yeah.
For this floating point, let's try. 2.3 raised to the power of 2.1. Is that okay?
Yeah.
Okay. 2.3 raised to divided by 2.1.
10.
This is integer division. So whatever
Yeah.
divide, it give me integer. So what is this?
It's possible.
Possible. So what is the answer?
Yeah. 1?
1. Okay. 2.3 percentage 2.1. What do you get?
It's the remainder. It's
Remainder, yeah.
which is yeah.
What you should just, can you guess?
It's 0.09? Is it? Or 0.1?
No, 2.3 divided by 2.1. The remainder is 0.2, right?
Oh. Oh yeah.
Right, but it's not 0.2. Why is that so? You see it's not 0.2?
Yeah.
Yeah, it's close to 0.2. It just missed by a little bit. All right, so here's the lessons that you must watch out. Floating point, you can do lots of things. Yeah, yes. But be careful, the number that you get is not necessarily what you expected, because computer doesn't represent all the numbers in the computer memory. All right, you will study computer organization, you will know numbers are represented in the mantissa and exponents, and not all the things can be represented. So these have to be very careful. So you don't expect 0.2. If you try to check against 0.2, you'll be in trouble. So here's another example. If you divide by 0.8, what will be the answer? 13.
Three.
Huh?
3.
3? Okay, no. It's 2. Why? You want to know why? You can just check this. What do you think you get? You get this. Once you get this, you divide by, if you take the integer, you only truncate, gone. 0.9 gone. 2 is the answer. All right. So this is another way, another place that testify that be careful when you're using floating point for some of this stuff. Generally, we don't like floating point. Right?
Okay.
In some of the computer systems, floating point is a no-no. They always use integer with a big integer. They blow out all the numbers so that they can deal with exact arithmetic. So computer is a very funny thing. Sometimes you don't get what you expect. All right. So to us, this it's 2.9999 is okay, but when you do an integer divide, you will get into trouble because obviously something which is close to 3 become a 2. So the difference is so much. Right? So this is dangerous. So a warning here, all these are doable, but be careful what you get. Okay, last column. Okay, let's try. There are two Isaac. Isaac Lam.
Hello. Can you hear me?
Very soft. Can you try louder?
Hello?
Yeah.
Okay.
Okay. String. Can I do addition of string?
Yes.
Yes. What do I get?
Directly combine the string next to each other.
Yeah, this is called concatenation. Can I do subtraction?
I don't think so.
Okay, correct. You don't think so. Can I do multiplication?
Yes.
Yes. Why?
It will like repeat the string that you do by that number.
This is multiplication. ABC 3 times. Indeed, ABC is 3 times. All right. ABC D plus EF. I do get that. Okay. Can I do division?
I don't think so.
You don't think so? Okay. Can I do exponent?
No?
No. Can I do divide, integer divide?
No.
Can I do remainder?
Probably not.
Probably not. Yes. Okay. So these are the few that cannot. What about less than?
Yeah. These
Yeah.
comparators.
Okay, let's try. 1 is greater than million. Is this true?
No, I think it will be false.
Huh?
I think it's false.
Why? $1 is less than $1,000,000.
Is it going
Or
by
what?
alphabetical order?
Okay, alphabetical order. Who comes first?
M.
Huh?
M.
M comes first. So M is smaller or larger?
I think it's larger.
No. When in front is smaller. You start with 1, 2, 3, 4, 5.
2, 3, 4, 5.
Okay?
Yeah.
Okay. What about this? 1 is greater than 1 million.
I think it's just 1 million, so it will be false.
Huh? This is false.
This is in numbers, right?
Is this number?
I think so.
No, they are not numbers.
No, the comma, is it?
Yeah, the comma is not number. So this is a tuple. Tuple. Tuple is to put a few things together into one. Now, putting a few items into one, but remember the order. Okay? So tuple. So this is actually the same as 1 compared with 1, then 0, 0, then 0, 0. That's why you get this.
Okay.
Okay? So anything that you write without parenthesis, in this case, this compare with this, give you false. This 0, 0, 0, nothing to compare is 0. This 0, 0, 0, nothing to compare is 0. Okay, if you don't believe, you can try 1 greater than 1, 0, 0, 1, 0, 0, 1. What do you think this is?
False 1, 1.
Yeah. Syntax error. Oops. I'm also wrong. 0, 0 in decimal integer literal are not permitted. Use and I don't know what is it for octant integer. Okay, so this is not allowed. This should be allowed. Okay.
Okay.
Okay. What about this? 1, 2, 3 greater than 1, 0, 0.
If they all compare like 1 by 1, then it would be false, true, true.
Yeah, that's your guess.
Yeah.
But your guess is not what the system guess.
No.
Yeah. This is actually
1, 2, true, 0, 0.
correct.
Okay.
Okay. What about this one? Or less than. This one.
2 should be bigger than 1, right? So it will be true.
It will be true. 2 is bigger than 1.
If I think about it in the same way as the alphabets.
Uh-huh. Yeah, correct. So this is so-called the dictionary order or lexicographical order. Okay. What about this? Integer of 1, 2, 3, 4, 5 less than integer of 2, 3, 4, 5. This one.
Now we're in numbers, so it should be false.
False. So because 1, 2, 3, 4, 5, it's not, yeah. Okay, so how do you know? One thing that I should tell you is that ordinal number of 1, it's actually equal to 49. Ordinal number of 2, it's 50. Ordinal number of A, small letter a, is 97. Capital A, this is how you have to compare. So if you compare A less than A, you will take the A is 65 compared with 97. So 65 is less than 97. So you get true. If you compare A, B with B, A, so what do you think this is? This A is 65. This B is 98, I think. This B is 98. So is this Isaac?
Yeah, I think should be true.
True. Okay, so you have to refer to the ASCII table, right? So the A is 65 and lowercase a is 97. Lowercase b is 98 and so on. So this is the ASCII table. You should know ORD, right? It's ORD, ordinal number. That means it's a Unicode of all this number. It's in this table. So when you need to compare 1, 2, 3, 4, 5, you compare character by character. 1 compare with 2. 1 is 49. Okay. So 49 compare with 2, 50. So 49 is already less than 50. So this is true. The rest no need to compare. All right. So this is the ASCII table. Okay. So much of that. Now I can go on to question number 2. Question number 2 should be easy. X is equal to 3. Y is equal to 5. And Z is equal to -2. So, first one. What is this? This is 3 plus 5 divided by -2. So this division has to go first. So this give me 2.5 minus. So 3 minus 2.5 give me 0.5. Yeah, okay. This is the next one. This is the remainder, and this is the exponent. So let's check. The remainder is number 6. Exponent is number 4. So this has to be done first, and then followed by this. So let's try this first. Y, it's 243. 243 remainder of x give me 0 because anything raised to the power is also divisible by x. So let's try fully. Yeah, so this is correct. Next, y less than equal to z. Y is 5 less than equal to -2, false. This one, x greater than z star y. So which one do first? Do you do x greater than z or you do z times y first? Let's see. Greater than sign. All right, so the logical operator, it's done later. So you have to do this one first, then this compare with that. Let's try. X greater than, oh, sorry, that's relational. X greater than z star y. So this is true. So z times y is -10. So x greater than -10. That's true. Okay. So this is the relation do last. Okay. Next, y divided by z, y divided by integer divide. So y is 5, x is 3, integer divide give you 1. So 5 integer divide 3 give you 1. Yes. This one. All right, again, the relation has to be done last. So you do this first, then you do this. Sorry, you do this first, and then you do this next, then you do this last. So of course, x plus z has to be the same as z plus x. In our case, we are integer, we are not floating point number. So this should be false. Okay, next, this one. Oops. All right, let's try. Daniel Ping Lu.
Should be 2.
True. Oh, to be 2. 1 plus 1, 2. Okay, let's try. Okay. Next.
42.
42. Okay. Next.
Should be 3.
Should be 3. Why? X is 3. 3
Yeah.
greater than 0, so 3. Okay. Okay, what about this?
2.
Okay, 2, because 0 is false.
Yeah.
So this is 1, else 2. Okay. Next, this one?
7.
7.
Because 3 is considered true.
Okay. Let's try. Let's try another one. If not 3x, 7, else what happened? Yeah. What about this?
Should be what happened here, because it's if not true, right? Then it's
Yeah.
7.
Yeah. Yeah, but this is syntax error. Why?
Because it's not defined.
Yeah. Okay. What is not defined? And happen is not defined. Here is not defined. This is a subtraction. This is a subtraction. So if you do what is equal to 1, happen is equal to 2. Here is equal to 3. Now you will try again. What should you get?
-4.
Yeah, -4. Okay, it was because what was not defined. I think this one should be easy.
1.
Let's go on. This one, if false 1, else y is 5, right? Is it?
Y is...
Y is 5.
Yeah, so it's false then.
It's false. Okay. If we change it to this one.
Then it's error, because we can uprun defined.
Huh? Week is defined. Oh, week is not defined. Okay. So week is equal to 10. Half is equal to 12. Let's
And
see.
-2.
Okay, great. All right, we are done with this one. So just a little bit more. Let me try this. Yeah, I miss out. Boolean 4. What is this?
True.
Boolean Z.
True.
Why? What is Z? Z is -2. -2 is also true.
Yeah.
Okay. What about this one?
False, because it's not, it's considered true, but it's not equivalent to true. Okay, wait, sorry.
Change
Uh,
Boolean.
yeah. Oh, then it's, yeah, true, true.
What about this?
Should be true.
Huh? You still think it's true? Okay, let's see. False. Yeah, what do you think? Why is this false?
Too many decimal places, maybe.
Yeah. All right, so this is again back to the question that dealing with floating point, be careful, huh? This number is too small to be representable as not as 0.1, 0.001. All right, so the number of precision is not good enough. Whereas this one still tolerable, huh? This one is still okay, huh? This one not so many zeros, but this one too many already. It cannot be represented anymore. As such, this is considered as a zero number, a number zero, and Boolean of a zero is a false. A false is not equal to the true. Okay, so be careful when you are using Boolean. All right, so and that's all we have for all this kind of like basic fundamental stuff that you should know. Okay, now we are at the last question. We can finish it by 9:30, and we want to write program. Okay, we want to write program for other people to read. So let's try. Okay, here you are supposed to design a point of sales, and basically you are writing programs to create, like in McDonald's, you have all these combo, and then you have bigger size and so on. So we want to write program. So can you paste your code at the chat box, and then I can take a look? Just some of you can, if you have it, you just paste it there. We can then discuss from there. Can I see some of your work? Just cut and paste into the box, and then we can see how you write the function. Write a function called biggie size, which when given a regular combo returns a biggie size version. A regular combo, it's one with one means one patty, two means two patties, and so on. Three means three patties, and four means four patty. So one will become, I cannot see. Okay, okay, all right. So I won. Okay, so all right, I have just one. Can I have some more? Okay, so there's one here. Okay. Mm-hmm. Okay, I just pick randomly. Okay. All right. Okay. Okay. All right, maybe we have enough. Okay. Okay, so we just take this view and then we see how. Okay, first one. This one, I cannot remember who has this. Anyway, you can see. So let's see some comments. Okay, Bruce Samuel.
Hello. Hello.
Hello. Yes.
Yes. Hello.
Okay. Yeah, can hear you. What do you think about this?
Hello. I think it's a bit of a shortcut because it just so happen all the biggie combo is +4 of the regular combo. For me, I would have use an if else statement where if combo equal 1 equal 1 return 5, if combo equal 2 return 6, if combo equal 3 return 7, and else return 8. But the option provided is also faster and it works also.
You wrote this. You mean this? Bruce, is this what you mean? Yeah.
I post my interpretation of the solution also.
Let's see. Yeah.
The most recent.
Yeah, so you wrote this. Okay. All right, so let's see Run. Run.
Yeah.
Yeah. What do you think about this? This is what Bruce wrote to us.
I think it works, but it's just a longer method compared to the first one, the regular combo +4.
Okay, so we are picking, we are trying to pick be very picky. In this case, this is considered as no good, all right, because a computer program is meant to be concise. And of course, this is correct. Everything is correct, but it's not concise. And why we write computer program is also because things can be described in a very succinct manner, and yet it can play wonder. Okay, this one is the same as listing out exhaustively all the cases. All right, so this is superior to this in the sense that this guy, if he passing 10, he will give you 14. All right, so this guy will be wrong in that sense. This guy will never be wrong except when the case, of course, if you passing 10, he also give you 8. All right, so that is also wrong. But otherwise, you can always say, you can add this. All right, and then else return error or something. All right, so this will be very precise, but yet this is not generally what we wanted, because computer program should be concise, and this is not concise. This is concise. On the other hand, this guy manages to keep checking of error, but I shall not, for this, I make a caveat here. This course does not require you to do error checking. All right, unless you are told to do so. Okay, error checking. It's important, but not for here. Okay, you will see that in software engineering course. All right, not here. All right, so both of these, okay, in this period, then I will accept this guy. But I should comment that this guy program is written for other people to read, but not just for yourself. This is a little bit verbose. All right, so you can just simply put combo. Okay, because you don't want to, in this case, we don't like this. Biggie size A. No, what is A? What is the input A? All right, but if you say biggie size combo, you know that it's coming in is a combo. All right, so relatively speaking, this is preferred than this, and this is also preferred to this. Okay, which is this. These two are the same now. Now, what is this one? One of you wrote this. I caught this. This is from Curtis. Curtis. Hello? Hello?
Hello.
Are you there? Cannot hear
Can you
you.
hear me?
Yeah, louder.
Hi.
Speak.
Hello.
Okay. So what are you writing here?
Uh, I used the anonymous function instead of the normal define function.
Okay. But one thing, you careless. This one you give side.
Sorry.
And so this is the, so you are using this as the function name. Okay.
Yes.
Okay. So this it's okay. It works up, huh? But again, same thing. I would rather not to use regular combo, or I can use combo. Of course, regular versus a biggie. Yeah, this will work also. Okay, so this is what we want to be very picky here to show that we wanted you to write program for other people to read, not for yourself. Okay, so this is a simple thing, but yet we can pick a lot of things out of this. All right, not to pick on you, but to pick on the program. All right. Of course, now you can write how to write unpicky size. Can I see some posting? What is unpicky size? Oh, so maybe I can post to you someone who we can also write in this manner. Here's another one. All right. So remember this construct 1 less than equal to combo less than equal to 4, then you return this. So this embraces or this encapsulate the error checking. Okay. It's within 1 and 4, then you add 4 to give you the biggie size. All right, so as I say, we don't need it for this course, but if you are told to do so, you do. Okay, just to give you more options to see. So let me see a little bit on your unpicky. Can you post it? Okay. All right, so this is just, as I can notice now, these are just reverse of what we wrote. So All right. So I see what you have now. So yeah, you learn it. You see that now you can do. So this is not good. This is not so good because this one is listing out explicitly. So this is not so good. Not so good. Okay. These two are preferred. Okay. So this is the normal one, right? This one has error checking. Okay, which you don't really need to do. Okay. Yeah. Okay. So we cover number 2. Number 3. Write a function called is biggie size, which when given a combo, return true if the combo is. So let's do number C. Can I see some posting on C? Okay. All right. Most people write this. What I'm seeing is not a. Let's I catch C. So I caught this. Oh. All right, this going through this is to tell you that there are many ways to do the same thing also. All right, so this is one. If biggie size combo, well, not if, it should be is. All right. Is biggie size. Right, if a combo number is greater than 4, return true, otherwise return false. All right, so of course this one, if you got negative number and so on, the error checking not there, but it's okay. All right, so combo greater than 4, then it's true. That's correct. If 5, 6, 7, 8. Otherwise, it's false. All right, but you actually this is a little bit verbose also. You could have written this, which will give you the same effect. All right, so this takes some practice. In the future, you can do this. All right, so return just simply greater than 4. You don't need to write return true, return false. It's simply return this checking. If it is true, it's true. If it is false, it's false. Same here. You return the combo is between 5 and 8, then it's true. Other numbers are not true. Okay. So this could be a better alternative to this guy. Okay, that is C. What about D? Let's see some D. D. Okay, some more. I see Isaac Tam. Okay. Come on. Okay, now I should pick up. E. Oh. Okay. All right, let's pretty much the same as I can see. Combo price, combo, if combo greater than 4, this means it's a biggie. Patty is equal to combo minus 4. You are trying to remove the patty. Then the return patty times 1.17 plus 0.50. This is the extra cost for the biggie. Okay. All right, let's get some comment from you. Okay, Leonard Godwin.
Yes, bro.
Yes,
Can you
can
hear
you
me?
comment on this? Can you comment on this?
Actually, Prof, I'm not sure why he do the petties equals to.
He does because it's a biggie, so he take away the four of them.
Okay.
Okay.
Yeah, then it works, Prof.
Okay, it works. So now we are not just looking for working. We're looking for beautiful. Simple. Okay, there's one thing that is this code it's not doing as in many other in the same way. Number one, reuse of code is not here. What do I mean by that? Leonard.
I think you mean you're not saving the cost of 1.17 and 0.50 as variables. So it's like magic number.
Okay, that's another thing. Magic number appears everywhere. So that is no good. All right. 1.17. Of course, this is a small program, but as I say, we're trying to pick bone, it's trying to make things very beautiful. So you should say patty equal to 1.17, and then this one should be removed per patty. This one should remove per patty. Okay, why is this better?
Because then if you want to change the price of the patty later on, you don't have to go through the entire code, which makes it less prone to errors if you want to change the price of the patty.
Good. So this is one. To avoid looking high and low to change next time, something like that. What else?
It's also
What
more
else
readable, Prof.
Yes. Okay. What else can I change? Well, a magic number. Is there any magic number?
Aside from the 1.17, you change got the 0.50.
Yes, that is extra equal to 0.5. So that should also be removed. Okay. Okay. What else?
You can also consider saving the 4 as a variable which may be named like is biggie.
No, that will not be good. Why?
Okay.
Now we settle this. This is done. Okay, look at this guy. Okay, there's one philosophy you have to always believe in coding. That is, the more you write, the more you need to test. And the more mistake is likely. Okay, so combo greater than 4. This is something checking about biggie, right? Did we do it? We did it here. Is biggie size or not? Correct?
Yes, bro.
Yes. So we should not do this. What should we do?
Should use the function. Should call the function.
Is biggie size. And then pass in combo. All right. What else? What else we can reuse still?
But yeah, I'm looking through the past.
The past.
Codes that we wrote, yeah.
What else?
We
Look
can
at
use
this guy.
the unbiggie size.
Yes. I don't need this. I can just simply do unbiggie size the combo. Correct? Okay, what else can I do? Actually, nothing else I can do.
And nothing else really.
Yes, okay. So that it's the changes that we have made so that we do take away magic numbers and we reuse code because the more you write, the more mistake you can make. Okay, that is a truth. We always like to reuse. That's also why computer is built in layer. So you always assume the lower layer are all done correctly. You are on top of the layer and you use thing in the lower layer. You don't want to rewrite the lower layer. All right. So in this case, the lower layer here means its peaky size is a lower layer, and peaky size is also lower layer compared to compose price. All right. So there is another. So you all agree to this, huh? Okay. Let me show you quickly that what's not so good. This is in the same spirit as what we had said earlier on to be verbose, and this is no good. All right, this guy works, right? It's biggie size, then you do this. Else it's not biggie size, you do this. This is no good. Okay. What else is not so good? This one is also not so good. All right, why this not so good? Planet. Okay. Should I call you Godwin or Leonard?
Actually, it's Godwin, prof.
Oh, Godwin. Okay. So why is this not good?
The issue of the magic number again, prof.
Magic number. Here one. Here one. What is good about this?
They catch a scenario where if the combo value is more than 9 or like less than 1, then it will return nothing.
Okay.
They catch
What
an
else is not
exception.
good?
Other than that, they also don't reuse the code. We can reuse the functions from before.
Okay, right. So we at least now we see magic numbers should not be appearing everywhere because program tends to change. I mean, when the inflation or whatever, the price has to change, and then you have to look through the whole program. That is a hassle, and you want to reuse code as much as you can. Great. Okay. So remember these 2 points, and then we have part E. You're supposed to write a function empty order. Okay, so this is a simple one. So it's simply this. I don't need to see yours. It's just simply this. And F. Can I see your F? Let's see F. What do you have for F? That's the last part. Wow. Isaac Thumb. Sure. Okay, so this is a common one. Isaac Thumb one is the first time I see. Let me try. Okay, so this is another common one, Daniel Ping. Oh, this is another one, Bruce. Put this. So usual one. Wow. Okay. Isaac Lam. That one, yeah, that looks very verbose. Okay. Self-awareness is the one. Okay, I have what I needed. All right. Basically, I see three methods. All right. This is new to me. Isaac Tam. Isaac Tam.
Yes, Prof.
Hi. So what
Hi.
is this trying to do?
Basically, it's just inserting in the two variables listed, the two parameters into the same string. So for
Okay, let's
example, x
try.
is 1, then y is 2, then it will give 12.
Oh, let's try.
Unless I did it wrong.
Okay, let's try. Add to order. 12, 3. 1, 2, 3. Let's look at the question again. Write a function called add to order which take an order and a combo and return a new order which contains the contents of the old order and the new old combo. For example, add to this, give me 1, 2. But what do you give me? You give me 1, 2, 3 string. This is printing the format into string, right? So
Yes,
this is not correct.
So can convert to integer.
Oh, yeah, you have to convert to integer.
Yeah.
Okay, so what you meant is this. You want to integer.
Yes.
Like this?
Yes.
Let's try. Okay, it works. Okay, this is one way. Where's my, okay. So this is one method, which I need the integer. Yeah. All right. So this is method 1. Method 2 is this. Method 2. All right. So basically, order is an integer, combo is an integer. You bring into integer into a string. You can concatenate the string. But again, this will ended up the same as what Isaac Tam did, and this need to be changed to integer again. All right, which is this guy. Okay, so I'll remove this. Then this is string integer. Yeah, this is the same as this one, so this is the same. I'll remove this. So this is the one. Okay, so this one is take order, multiply by 10 to shift it by one integer, then add it. So how does this work? So let's see. All right, so if you do, you get it correct. Oops, it's wrong. Why? One, two. Oh, this is the wrong. Oh, I see. A combo means an integer. So this is against the input. All right, so you cannot have 3, 4, 5. It's not a combo. Combo means 1 to 8. All right, so this is not a valid input. So if you do have error checking, then this will be called. All right, so it should be like this. It's 1, 2, 5. Okay, so we have three methods. Let's try. Okay, back to Isaac. What do you think? Isaac Tam. Among these three, which is the better one? Or is there a better one?
For me, it will be the second method because it's better for readability.
Okay, you don't like the third one. Method 3. You don't like?
I think it works, but I'll prefer
Yeah.
method 2.
You prefer method 2?
Yeah.
Okay. So when we talk about prefer or not prefer, we usually have two items that we can check. We check of the resources. It's the time and space. Okay. So time is money. All right. Time means how long does it take to finish the work. Space means the amount of storage you need. Nowadays, space is quite cheap. Okay, but with respect to this, so method 2 will require me to, the time will require me to do it to convert this guy into a string. All right. Then this guy also into a string, then concatenate, then do the convert it back to integer. All right. And that is the time you need. You need to do 1 operation, 2 operation, 3 operation, 4 operations. Of course, individual operations has a different timing. Now look at this guy. This guy is taking this order multiply with 10. Multiply with a 10 is not that difficult to multiply. Of course, well, in the computer, it's still binary. It's still 1 operation. This could means, but this is common, all right? It's commonly available. Then you plus the number. So this is simply 2 operations with a multiplication and a plus this. So the time-wise, this guy has 2 operations. So the time. What about the space? There's nothing much we can talk about the space here because of course, maybe one thing. This order need to put into a string, you use up some space and then you put into integer. This one also put into a string, then concatenate. So this one does use some extra space. Whereas this one, very little space needed. This side is only 10 multiply, it's another number. Then plus this, which is the input number. Okay, we didn't talk about this one. This one is I believe this is printing, which will be similar to this kind of thing, and then take the integer. So if we talk about only these two, myself would prefer this guy. Okay, why is that so? My rationale is that this string thing is converting. This conversion, it's very unusual. Let's try string of 1.234. Will it give me? Okay, it does. So this guy is very powerful. So the algorithm to do this conversion, could be very hairy. Whereas this one is simply a multiplier with 10. Okay, so besides taking this as a string, you have to convert it back to integer. Again, this is another hairy thing. I'm not so sure how this is done. All right, so myself, there's no right and wrong, but in terms of time, I would prefer this guy. Moreover, I should tell you that Python has a very large integer. So for example, in other languages, if you put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, and so on, all right, such a number will not be not representable by a computer in that language. But in Python, there's no problem. This number is still this number. So Python is dealing with large number easily. Okay, of course, it comes with the costs, but it does represent faithfully the integer number, right? Unlike floating point number, unlike integer in other languages. So you can check, for example, large this integer in Java. Okay, for example. All right, so Java has this largest integer. All right, so this anything larger than this will be overflow and it will not be representable. But in Python, no issue. Look, this number is much, much bigger than this number. Still no problem. So that is to say that whenever I have an order, I multiply with 10, I have no issue because this number will be faithfully represented and added with the comp. Okay, so once again, there's nothing right or wrong. Even though we say this is verbose, but still it works. In terms of practicality, there's nothing I can deduct. But there is a difference between a good programmer versus a lousy programmer, you know. So we want to train ourselves to become good, that we write things readable, easy to understand, and so on. So we will follow best practices. So you always have to learn what are the good practices. Like you should know if precedence is an issue, you should parenthesize them to avoid confusion. When talking about naming, right? Naming, you should do star guide for code. You should read something like this to help yourself and to help other reading your code. All right, your TA should be telling you at time that if you're writing something which is difficult to understand. Okay, so integer, largest integer in Python is always possible. And I will pose a question here. That's all I have for today. Any question? I think we are done with, there will be part 2 in recitation number 2 for this question, but that will be easy. If you have no issue, give me a check that you are okay. And we should always try to finish by 9:30. Okay, you have question, you can ask. If not, you can leave. Or your attendance is captured automatically by Zoom. Oh, there's no deadline for whatever question I'm posting to the forum. It's just simply for enrichment. Just there is also something which I encourage you to do, because we also do that to set exam and midterm questions, inclusive of practical exam. We ask question. You should not stop asking questions. By seeing something, you can challenge yourself, like what you saw just now, right? What you saw earlier on, all these things, is because I ask questions, and you have to learn to ask questions. And whether it's good question or just some dumb question, but we learn along the way. Oh, you didn't get the tutorial, the recitation question? Or it's all here? It's a lesson plan. Here, how you join, you got the recitation here. Here's it's under lesson plan. You can also go to Workbench recitation. They're all the recitation. Of course, these are not arranged in the order that you're supposed to learn. So you should go to lesson plan. All right. So this week we have recitation. Tomorrow I have a repeat, which is the same recitation. I will put the recording tomorrow here. And then next week you will have tutorial. Next week I will have a review on lecture 3, but the tutorial will be here by the TA. This tutorial you're supposed to submit. The tutorial is supposed to be submitted. It's in, let's see. Okay, you can do filter here to take this tutorial. Okay, tutorial. So tutorial 1 here. Oh, not here. Here. You have to click here to work on the tutorial. And then next week, this one is to go to the tutorial. You have a question here. Next week, the TA, the senior TA will go through the tutorial through Zoom. And this presentation. This is next week. Next week, I will do the lecture, and the TA will do the tutorial. Tutorial 1. Okay. All right. So the discussion it's on what you have done in here next week. Oh yeah, sure. There's a question, Jordan. Python can handle large number. Of course, there's a penalty issue. Yes, because the large number is not native, basically. It's not primitive in a way. But I do not know how it's done. Some of this stuff, you know that it's there, but surely this number is a bunch of numbers make up to be this number. So there's a cost. Yes, there's a performance issues. But working with integer, it's always the preferred mode. Your alternative is to work with floating point number. But as you saw, floating point number can cause trouble. I'm in geometry, okay? I work in computational geometry. This is the area. All right. In computational geometry, 3 points, 2 points form a line, right? 3 points on the line in 2D may not be represented in computer, may not be, I can make it stronger, may not be able to be represented in computer as 3 points on that line. Okay, so there is a trouble. Whenever you have 3 points, you want to make it into a line. 2 points form a line. The third point that you pick on the line may not be represented in computer as a point on the line. And it can cause a lot of computation to fail. This is in the area of SOS, simulation of simplicity, if you want to find out. Okay, Jordan, this is a big topic. Any other question? If not, then just goodbye. Just leave and see you next week. Okay, you can leave and we can shut down now. Oh, one new one. Thank you. Bye-bye.
Thank you. Thank you.
Thank you.
Thank you.
Thank you. Okay, you can see the recording tomorrow morning, I guess. Bye-bye. Usually the Saturday session, it's less error from me because when you talk for the first time, sometimes you make mistakes. But otherwise, Saturday one is more accurate always. But of course, you want to listen to your own. Thank you. Bye-bye. Okay, just a few of you. You have to quit. Okay, I stop the recording now.